Let's talk about the intersection of a plane and a line. So the thing that we want to realize here is that these will always have a point of intersection with one little condition that we have to meet. And what is that condition? As long as the line is not parallel to the plane. But let me just, to show off here, use like my hand and a pen here. So like my hand is meaning to be some kind of plane here. The pen is going to be, the marker is going to be some kind of line here. So I have a plane and a line. These are going to intersect in exactly one point right here in my palm. And except that we have to be careful that like we could have this plane, or you could just think of, you know, this piece of paper here as the plane, and the marker is just parallel. I know it's kind of hard to see this on a video here. And the marker is parallel to the plane. These aren't going to intersect. One other special case I should note here is that it is possible for there to be infinitely many points of intersection if the line is exactly inside of the plane. So if the line is part of a plane, then the entire line is the set of intersection points with the plane. Okay, so in general though, as long as we're not in one of these special cases, we should be looking for exactly one point of intersection. And so let's go ahead and do an example of this. So find intersection point of the line with parameterization. R of t is 2, 1, 0 plus t times 3, 0, negative 7. And our equation of the plane here is going to be 2x minus 3y plus z is equal to 5. How do we do this? Well, we're going to want to solve an equation here, and we get this by thinking about the x component, the y component, and the z component of r of t as a function of t and plopping them in for x, y, and z respectively. So what do we end up with here? The x component, the first component, is going to be 2 plus 3t. So we replace x here with 2 plus 3t. Our y entry is 1 plus 0t. That's just 1. So minus 3 times 1. Our z component is 0 minus 7t. So I replace z with negative 7t. And now I have a very easy equation to solve here for t. Let's just do that real quick. So 4 plus 6t minus 3 minus 7t is equal to 5. So that would be 1 minus t is equal to 5, or t is equal to, t would be equal to negative 4 here. Now, let's just realize here that this isn't our final answer. We always need to be answering the question that is being asked here. This is the value of t. So let's plug in t up into, let's plug it in up here. So r of negative 4 would be 2, 1, 0, minus 4 times 3, 0, negative 7. And so this would be 2 minus 12 is going to be, 2 minus 12 is negative 10. 1 minus 0 is just 1. 0 minus 4 times minus 7 is plus 28. So here is our point of intersection. To maybe put an end to this problem, let's check that our answer is correct. Let's go ahead and plug in x, y, z up in here to make sure that all of this checks out. If we don't get this, something's gone wrong here. So 2 times negative 10 minus 3 times 1 plus 28. So that's negative 20 plus 28 is plus 8, minus 3 is 5, and that checks out. So that's how you find the intersection point between a plane and a line, assuming that it exists. If these were parallel to each other, you would just get no solution here.